So multiplying rationals. Make sure to factor numerators and denominators if possible before you multiply. Remember, you can multiply and then cancel common factors, or you can cancel common factors in the numerators and denominators and then multiply. Remember, you just multiply straight across. You do not need a common denominator when you multiply fractions. So for this one, you can just multiply straight across. Remember, when you multiply like bases, you add the exponents together. So it'll be 21 x to the 13th y to the 5th over 5 times 35, which will give me 175 x squared y to the 4th. And then you can simplify. So 21 and 175 have a common factor of 7. So this is going to reduce to 3 over 25. X to the 13th over x squared. Remember, you subtract those powers. That's going to give me an x to the 11th. Y to the 5th divided by a y to the 4th will give me a y to the 1st. So when you have rationals, you want to make sure you factor wherever possible. Remember, x plus 5 is actually a fraction over 1. Times x squared minus 36 is another difference of squares, so I can factor it into x minus 6 times x plus 6. I can factor this trinomial, which is going to be an x plus 5 times x plus 6. Now you can cancel common factors if one is in the numerator and one is in the denominator. I can cross cancel that x plus 5. I can cancel out the x plus 6. So my final answer is going to be an x minus 6 over 1, or an x minus 6. So when you look at number 17, you can factor an x out of this numerator. That's going to give me an x minus 2. Factors of 1 add together give me 2. This factors into x plus 1 times x plus 1. Factors of 3 add together give me 4. X plus 3 times x plus 1. And I can factor out an x. Notice I have an x plus 3 in the numerator and denominator. I can cancel. X plus 1 in the denominator, x plus 1 with the numerator. I also have an x in the numerator and an x in the denominator. So now what's left to multiply straight across, the only thing in the numerator is an x minus 2 over an x plus 1. Remember, dividing is just like multiplying, except you have to multiply by the reciprocal. So for example, remember, you always take the reciprocal of the fraction that comes after your division sign. So I know I can factor this into x plus 12 times x minus 2. Remember, this is a fraction over 1. Times, remember, I'm going to flip this fraction. I can factor 3x minus 36 with a GCF. That's going to be a 3 times x minus 12. So now that's what's going to be in my numerator. X squared minus 144 is another difference of squares, so that factors into x plus 12 times x minus 12. So now I just treat it like a multiplication problem. I can cross cancel the x minus 12, cross cancel an x plus 12. What I'm left with is a 3 times x minus 2, and you don't have to redistribute it. You can leave that alone for your final answer. So when you have a problem involving trig functions, like I said, you can just multiply straight across. This gives me 15 sine to the 3rd theta cosine squared theta over 10 sine squared theta cosine theta. Again, 15 and 10, you can divide a 5 out. That's going to give me a 3 over 2. You have sine to the 3rd here, sine to the square on the bottom. Subtract 3 minus 2, I end up with a sine theta in the numerator. Cosine squared divided by a cosine will give me a cosine theta in the numerator. Now, when it comes to adding and subtracting, remember, you add the numerators and you keep the denominators. Remember, you have to have a common denominator, so if needed, you have to rewrite both fractions with the same denominator. So you have to identify the LCD. Factor if you can. So this factors into 2 over x plus 3, x minus 3. So my LCD, x minus 3, has to be in the LCD. Every factor has to be in your LCD. In my second fraction, I have an x plus 3, x minus 3. I already have an x minus 3, but I have to include that x plus 3. So what you have to do before you add is rewrite each fraction so that it has the same denominator. You already have an x minus 3 on the bottom of this first fraction. but you're missing the x plus 3. So this is where you have to multiply top and bottom by your LCD. So I have 3x times x plus 3 over x plus 3 times x minus 3 plus the second fraction. You already have the least common denominator, so you're good for this second fraction. So you do have to distribute the 3x. That's going to give me a 3x squared plus 3x times 3, which is a 9x. Now that I have the same denominator, I can combine this into one large fraction. And there's your answer. Again, if possible, you wanted to check to see if you can factor the numerator and cancel if you can. So in my second fraction, I have an x minus 3 on the bottom. I need to factor this denominator into x minus 3, x minus 2. So in order to add these two fractions together, I have to identify my least common denominator. I have an x minus 3 on the bottom of this fraction. I already have an x minus 3 in the LCD, but what piece is missing is the x minus 2. So I have to multiply both fractions. I have to rewrite, both fractions with the LCD of x minus 3, x minus 2. My first fraction I already have an x minus 3. So I have to multiply my numerator by an x minus 2, my denominator by an x minus 2. So I have x minus 1 times x minus 2 all over your LCD. Plus the second fraction, you already have your LCD. So now you are going to have to FOIL this numerator. So x times x is an x squared. Minus 1x minus 2x is a minus 3x. Negative 1 times a negative 2 is a plus 2. Plus 2x. Now that the denominators are the same, you can combine this into one large fraction. Notice you can combine the 2x and minus 3x. That gives me a minus x plus 2, and x minus 3, and x minus 2. You cannot factor the numerator, so we're good there. So that takes care of, these are some additional practice problems if you need them.